Comprehensive Code YouTube channel. Today we'll be solving lead code 212812. Find the safest path in a grid. Let's read the question first and really understand it. Let's go over it. You are given a zero index 2D matrix grid of size n by n where RCA represents a cell containing a thief if grid RC is 1. For example, if the grid RC is 1, it represents there is a thief in this grid. An empty cell if grid RC equal to 0. So for this one is empty cell, and you are initially positioned at cell 0 0. So we are initially positioned here, and then in one move we can move to any adjacent cell in the grid, including cells containing the thief. So if we are here in this grid, for example, we can go up, right, or left, or down. Even if there is a thief somewhere, we can go in that path. The safeness factor of a path in a grid is defined as minimum Manhattan distance from any cell in the path to the thief in the grid. So basically what it means is the safeness factor of a path. For example, if this is the path, the safeness factor of this path is 0 because the safeness factor here is 0, and we have to return the maximum safeness factor of all paths leading to that. So for all paths leading to the destination, we have to provide the maximum safeness factor. So in this case, no matter what, if you go this path or this path or this path, you always start from here, which is the thief position. Like this grid position has a thief. That means no matter what, which path you follow, the maximum safeness factor will always be 0. But let's take this example and see what maximum safeness factor is. Okay, for example, on this one, let's go through in the code editor and then put it in a diagram so that it will be very easier for us to understand. So let's go here. This is the matrix we have. The safeness factor for this grid is, this particular grid is 0 because the distance is 0 from the grid itself. And in this one, because the thief was here, the distance from the thief to this grid is 1, and similarly the distance here is 1, and the distance here is 1 and 1, that is 2, and then distance here is 1 and 1, that is 2, and distance here is 1 2 and 3, distance here is 1 2 3 4. Also, like if you go from this path, 1 2 3 4, so it's 4, and distance here is 1 2 3, and distance here is 1 2 2. All right, so this is the distance. Now let's see, if we go from this path, the maximum safeness factor is 0 because here we encountered 0. But if we go this path, the maximum safeness factor is 1. Okay, and then if we go this path, the maximum safeness factor is 1. If we go this path, the maximum safeness factor is 2. Okay, and then if we go this path, the maximum safeness factor is 2. I hope the question makes sense. Now let's dive into how we can come up with a solution for this problem. The way I'm thinking this problem, to solve this problem is in 3 steps. First, let's write this. First, what we can do is find the grid with thief and add the grid in Q. Okay, first is that, so let's name this as maybe tip Q. Okay, and then second what we can do is we can basically do a breadth first search to fill the distance between the nearest thief and another grid, so that we will fill up the distance like this in this grid. So do a breadth first search BFS to fill the distance, Manhattan distance, in the grid. Okay, and then third, what we can do is, once we find out that, what we have to do basically is do a shortest path Dijkstra's DJASTR DJAKSTRA Dijkstra's algorithm shortest path Dijkstra algorithm visiting from the origin to the destination. Okay, that is the third step. Okay, what I mean this by this is, once we have this, what we'll do is basically we'll maintain a max heap. Okay, max heap that will be, the max heap will be okay, the max heap will be -2, because we are maintaining a max heap, not mean heap, so that like the Python has mean heap, so the only way we can do it is storing it in negative value. Also, we'll also store the row and column. Basically, that will be this one. Okay, all right, so that will be that. And then once we have that, what we'll do is we'll start iterating from here, and then we'll find the minimum of this, the neighbors, minimum of the neighbors. So we'll visit the neighbors and find the minimum. So what is the minimum between this and this? 1 is minimum, so the max heap will be so the value or distance will be distance row and column will be, if we pop this max heap, what this will be is like 0 0 and 0. Okay, now max heap is empty because we popped that, is now empty. Now we'll go through the neighbors of this, and what we'll add here is, let's put it a little down. Okay, so what we'll add here is okay, so we'll add the minimum of the neighbor. What is the minimum between this and this? It is 1, and then the coordinate is 0 1, right? And then another one is the neighbor is this one. What is the minimum between these two? And we should store it in negatives because we are maintaining maximum here. And what is the minimum of between this and this? It is 2, right? So we'll do -2, and then the new coordinate is 1 0 1 0, right? And then in the next iteration, when we pop this max heap, this will be at the top because this will be the minimum value, and we pop that, this will be popped. Basically in the next loop it will go here, and then what we'll do is we'll also update the value, the grid value, to the minimum one here. Okay, all right, so we'll do that, and once we do that we'll do the same thing here, and then the 2 is here, it will go here, and then here it will be 2 because it will be updated to 2 here. And then once we reach here, and then it will start visiting the neighbors, it will find the 2, and then at last it will return 2, and 2 will be the answer in this case. Okay, so let's let this, and 2 will be the answer, right? All right, I think that makes sense. Now let's start the coding part. So as we said there, we'll find the grids, thief grid, and add it in the queue. We'll populate the distance with BFS, and we'll use Dijkstra's algorithm to traverse to find the maximum safeness factor. All right, so first thing first, when we solve matrix problems, we'll do n rows and columns equal to length of the grid and then length of the grid 0. Okay, and then let's define. So first thing, we have to find the thief's grid. Therefore, we define a function, prepare thief's grid. Okay, and what it'll do is thief's grid is equal to that. Okay, that is the thief's grid. And let's put a DQ. Okay, and then for row in range and rows, for column in range and calls. So thief's grid, if our grid of row and column equal to 1, basically if there is a thief, then we append the value. Okay, the value is 0 because the distance will be 0 from the thief position, and then we add the row and column. Okay, and then at last we return thief grid. Okay, so now we prepare that. Let's call that. That is the thief's grid, right? Now we have to populate the distance with BFS. So let's do that. Let's write a BFF function. Breadth first search, and then what we'll do is we'll have a queue. DQ, or just pass that. I think that will be that makes more sense. So what we do here is, while we have thief's grid, what we have to do here is also, let's mark this as grid row and then column. Let's mark this as 0, and then if this is not a thief, let's mark that as row column equal to -1. Okay, so that we know like the distance is 0 in this case, and then for the one that doesn't have thief, we can populate the distance. Okay. Also, we will be going in 4 directions, so let's define that directions is 0 1 0 minus 1 1 0 and then minus 1 0. Okay, that's good. And let's go here and see the distance row and then column is thief's grid pop left. Okay, and then also we need to check, like if we are here, we need to check if I go to left direction I'm out of bound, and up I'm out of bound. We need to make sure like we won't go out of bound. Let's define that function as well. Row and column return 0 is less than or equal to row is less than and rows, and 0 less than or equal to column is less than and calls. Okay, and then let's see, if in bound row and then column, if we are in bound and our grid row column equal to -1, okay, that means like it doesn't have a thief because we mark that as -1 here. Now what we can do is basically grid. No, so we need to travel in all 4 directions. Y in directions. Okay, so the new x, new y is x plus row, y plus column. Okay, and we should be checking if this new x and new y is in bound. New x, new y is in bound. Okay, so if that is in bound and it doesn't have thief, what we have to do is grid row and column new x, new y, sorry, should be the distance plus 1, right? Okay, once we have that, what we can do is we also have to add this particular grid in thief's grid so that we can visit all the cells. And distance plus 1 and the new x and new y. Okay, that's good there. All right, once we have that, let's call that BFS as well. Now the distance matrices will be filled. So now the part remaining is the Dijkstra's algorithm to traverse to find the max safeness. So let's define that function. Okay. Define that max safeness. Okay, and what we'll do here is, as mentioned earlier, we'll define a max heap, and we will put negative of grid 0 and then 0, which is the source, and then the coordinates. Okay, and then while max heap, what we'll do is safeness is, and row and then column, we are defining those, and we'll heap up max heap. Okay, and then if this row and column happens to be the destination -1. If it happens to be destination, we'll just return the negative of stiffness, because we're storing that as negative value here to maintain the mean heap. Okay, and now if not, then we have to traverse through all the directions for x, y in directions new x and new y is x plus row and then y plus column. Okay, all right, so now what we have to do is we have to check if this is in bound new x new y. Okay, if that is in bound and our grid row and then column, oh sorry, the new x and new y not equal to -1, if it is not visited, then what we have to do is we have to heap post the max heap. In max heap, what we have to do is the negative of minimum of our safeness and then grid new x new y new x and then new y. Okay, let's put that in tuple. Okay, and then here we'll also put new x and new y as this format. Okay, the value and then the coordinates like this. And now also, like, we have to mark this as visited new x and new y is equal to -1, so that we won't visit it again and again. Now let's call this return max safeness. I think that should be it, and if you cannot reach the destination, we just return -1. Okay, all right, so that is it. Basically, find the tip in the grid and add it in the queue down here. Okay, and then you have to do BFS to update the distance in the grid. Okay, and then you have to find the maximum safeness using Dijkstra's algorithm here. Okay, so now let's see if we can test this. Okay, let's do this, and for this scenario we are taking this as an example. Let's see, 1 0 1. Okay, I think it was 0. Okay, let's run this. Okay, Thip's grid propositional argument. Okay, Thip's grid. Okay, BFS, we have to pass Thip grid here. Okay, now let's see pop left. It does not have pop left. Okay, Thip's grid, it says Thip's grid does not have pop left because we don't call that as function. So let's see, 3, is it 3? Right, let's take an example from the lit code itself. So this one. Okay, this one, so it is 2, this is 2, and let's go and run this code in lit code. All right, let's run this. As you can see, it runs, and then let's submit it. And it's accepted, and it's pretty efficient. If you find this helpful, just subscribe to my YouTube channel, and if you have some confusions, just let me know in the comment section below. I'll try to reply you as soon as possible. Thank you.